So there's some more lines and segments related to circles that you may not be familiar with. First is a chord, which connects any 2 points on the circle. A diameter is actually a special chord that goes through the center. There's a secant, which is like a chord, but a chord's a line segment, and secants are lines that go on forever. And then there's a tangent, and a tangent only touches 1 point of the circle. It just kind of, if you imagine a circle and you try to put the circle on a table or a flat surface, when you stand that circle up, the only point that touches the table would be the tangent, and the point that touches would be the point of tangency. So if you imagine taking a coin, which is a circle, trying to stand it on its edge on a table, the table would be a tangent to the coin. A perpendicular bisector of a chord will go through the center of a circle. It's just a theorem. It can be proven. And it's a simple way to think about it. If you draw the radii to each point at the end of the chord, we know the radii are congruent. We've got a right angle because it's perpendicular bisector, it cuts it in half. So since it's equidistant, that would be the center, because the end of the circle is equidistant from the center. Also, there's angles related to chords. If two chords intersect, the measure of the angle is half the measure of the arcs. So if we call that x and y, the measure of the angle formed by those two chords is 1/2 x plus y, or 1/2 AC plus BD. So here we have an example where one arc formed by these two chords is 60, the other is 90. So the angle formed in between is, I'm trying to find the angle AEC, this one, but they'll be equal. The angle formed is half the sum of the two arcs. So it's half of 60 plus 90. It's half of 150. So the angle is 75 degrees. Also related to chords, the chords cut each other, not into half but into pieces, and those pieces, if we call the lengths of those pieces that they cut A and B and C and D, for chords, A times B equals C times D. Or if you think about it in terms of segments, AE times BE, CE times DE. So to find the measure of an angle, it's the average of the two arcs. So 1/2 of 40 plus 60, it's 1/2 of 100, which is 50. And find the length EB, we'll call it X. And part times part equals part times part. So 8x equals 6 times 16. 6 times 16 is 96. 8x equals 96. Divide by 8, we get x equals 12. So EB is 12. In a circle, you can also have two secants that intersect outside the circle. And if the angle is outside the circle, it's 1/2 the difference of the arcs. So you subtract the two arcs and divide by 2. So here we have arc BD is 20 degrees and arc AC is 80 degrees. Find the measure of angle AEC, which is the angle right there formed by the secants. And that will be 1/2 the difference of the arcs. So that's 80 and 20. 80 minus 20 is 60. Half of 60 is 30 degrees. Also with secants, you can look at the segment lengths. There's the inside portion of the segment and the outside portion. Inside portion and the outside portion. Or you can look at the entire length from where the secants intersect to the opposite end of the circle. And the formula is AE, the entire length, times BE, the outside portion, equals CE, the entire length, times DE, the outside portion. So it's outside portion times the entire length. For each secant, they are equal. Outside times whole equals outside times whole. So to find the measure of an angle, CAE, CAE is the outside angle here. So we would do 1/2 the difference of the arcs, so subtract 90 minus whatever this arc is, divide by 2 will tell us the angle. We have 110, 90, and 120. That's 200, 320 degrees, which means there's 40 degrees left for that portion, that arc. So the angle will be 1/2 of 90 minus 40. So 1/2 of 50, the angle is 25 degrees. And find the segment AD. AD is the outside portion. And the formula, as I said before, was outside times whole length. So the outside portion, x, times the whole length, x plus 19, equals the outside portion, 5, times the whole length, 5 plus 16, which is 21. Five times 21 is 105. If we distribute our x, we get 19x plus x squared. So x squared plus 19x, we'll move the 105 over, subtract 105, equals 0. So we have a quadratic equation, so let's use the quadratic formula to solve for x. And using the quadratic formula, we get negative b, negative 19, plus or minus the square root of b squared. 19 squared is 361. Minus 4 times a, 1, times c, negative 105. So we have minus 4 times negative 105, would be negative 420. So minus negative is plus 420. all over 2 times A. A is 1, so all over 2. So 361 plus 420 is 781. The square root of 781 is almost 28. It's 27.95. So if we subtracted, we get a negative answer. It's a distance, it's a length, so we can't get a negative answer. So that one can be thrown, the negative answer can be thrown away. So negative 19 plus 27.5 is 8.95. Divide by 2. 4.47, 4.4, or we could say 4.5. Go with 4.47. A little bit more accurate. So AD equals 4.47. So we'll pretty quickly go through some other theorems related to tangents and things like that. Radius and a tangent are always perpendicular. There's more angles also if we take a chord and a tangent, or a secant and a tangent, or 2 tangent lines. A chord and a tangent would actually fall, it's similar to an inscribed angle because the vertex is on the circle, just like inscribed angles. So the measure of that angle is still half the arc that it cuts. It just looks a little bit different, but it's still kind of like an inscribed angle. If you have a secant and a tangent, remember when we had 2 secants, it was you subtract the 2 arcs and divide by 2. It's still the same thing when it's a secant with a tangent. Subtract the 2 arcs, big arc minus little arc divided by 2. And 2 tangents, still the same formula, this time big arc minus little arc divided by 2. But the only thing that's unique about 2 tangents is big arc plus little arc would equal 360. So you really only need one number here, because you could find the other by subtracting from 360. So here's an example. We're told that CD is 120 degrees. Find the measure of angle BAO up here. So as a bit of a hint, they've drawn in the radius for us on both sides. Radius is perpendicular to the tangent, so we do have that these are right angles. And since BO and CO are both radii, they are equal to each other. And also, if we just look at AO, that's the hypotenuse, and it's shared in both of these triangles that we split it into. And therefore we have a right angle with 2 legs, leg, the triangles are congruent. The hypotenuse, sorry, not the 2 legs, the hypotenuse and leg are congruent. So we do have congruent triangles, which means BAO and CAO are congruent angles. Also, since this goes through the center, it's a diameter, which means if this is 120 degrees, this arc must be 60 degrees. So the angle over here, OAC, is going to be big arc minus little arc divided by 2. So that's 60 divided by 2, so the angle is 30 degrees. BAO is congruent, so it is also 30 degrees. Here's another property related to segment lengths. Two tangents that intersect each other outside the circle, obviously. The length from the point of tangency to their point of intersection is equal. Two tangents are congruent, the tangent segments. And if you have a tangent and a secant, I mentioned before that we took the outside portion times the whole length. With tangents, the outside portion is the whole length. So it would be BA times BA equals outside portion BD times the entire length BC. BA times BA equals BD times BC. Outside portion times whole, outside portion times whole. So here we have triangle ABC. All the sides of the triangle are tangents to the circle that's drawn in it, circle O. So that there's a vocab term that goes with that. Circle O is inscribed inside the triangle. If P, Q, and R are points of tangency, find AR and BP. AR and BP. Well, these are all tangents, so that means all of the segments here, the tangent segments, are congruent. So if, rather than marking, let's pick a letter and use for the lengths. X, Y, and Z. Since we know the total lengths of each side, we know that X plus Y is 3. X plus Z is 4. And Y plus Z is 5. We can pick two equations and combine them. So if we subtract the second equation minus the third equation, we would have negative x plus y. Z minus z is going to cancel. 5 minus 4 equals 1. And then let's use our top equation. We can add these two equations together to cancel out the x's. X and a negative x is 0. Y plus y is 2y. 1 plus 3 is 4. So if 2y equals 4, y equals 2. And if y equals 2, 2 plus z equals 5. So z equals 3. Also, if y equals 2, then we have x plus 2 equals 3. So x would equal 1. So x is 1, y is 2, z is 3. X is 1, y is 2, and z is 3. Find AR. AR is 3. And BP is 2.